Palindrome is a word or a phrase or a number or any sequence of characters that reads the same forward and backward, and you can ignore the spaces, punctuations, and capitalization. The question says that given a string, find the length of the largest palindrome that can be made from the characters in the given string. Hi everyone, welcome to yet another video where we'll be solving one of the interview-based questions. Now, my name is Ravi, and I have more than 11 years of experience across the tech industry. I worked on a bunch of different profiles, including backend engineering, data engineering, cloud engineering, and I have dealt with a bunch of different tech stack, I would say. I like to help learners in my casual time. I like to help them with interview queries, questions, some suggestions on their careers, and probably if they have some questions regarding any roles, any companies as such. So that's a bit about me. Let's get started with today's session or today's question, I should say. So an example is given. If you see the string here, it says race car. So if you carefully observe, you read it from the front or from the back, it kind of translates to the same string, race car. And essentially with this input, the longest palindrome that you can make, the length is 7, RACECAR. So that's the output, the longest or largest palindrome, but I would say it's the longest palindrome, as the question title says. Similarly, another input is given, just for your better understanding. We have double A, double B, double C. And the length of the longest palindrome that we can make is 6. Now, one might think, how is that possible? So let me just give a bit of clarity around this. So let's say if we have this, what palindrome can we make from this? So we can have something like AA on both sides, then we can have BB on both sides, and then we can have CC on both sides. So if you see, ABC, CBA, and you read from this side ABC, CBA. So that's a palindrome, by the way. And that is the longest one that you can make out of these given string. And that's why the answer is 6. I hope the question is clear now. We are pretty much clear on what the input would be and what are the expectations as far as output is concerned. Now, let's get started with this. And the very first thought that I have around this is I'm thinking right now about the strategies, about the way in which we can create a palindrome. Just a bit about this question, by the way, before I get started, I want to acknowledge that this is a pretty I would say pretty good question to test the coding skills, to test the problem solving skills for data engineers or even data scientists. Although this problem would be categorized, generally you would see people categorizing it as an easy one, but still, I would say it's not that straightforward also. And it falls in the space where it can be used, it can provide a fair evaluation of the problem solving skills and the coding skills for a data engineer or a data scientist people. So on that note, let me resume my discussion. So the strategy which I am thinking about how we can create a palindrome. So one of the first thoughts that is coming into my mind is that, okay, if we have a given string, I think one of the first strategies is that we need to think about, let's take each character from the string and let's try to see if that is a palindrome or not. And this is the most naive solution that we can think about for this. For example, I can take A and I can see that, okay, if that's a palindrome or not. Then I can take AA. I can see if that's a palindrome or not. I can take AAB and then I can see if it's a palindrome or not. And accordingly, with respect to this A, I can go on try forming a string with the remaining characters and try to see if that's a palindrome or not. That's one very naive way I'm thinking right now. And this way, like once we are done with all the characters with respect to this first A, now we can omit it. We can take this second A, and now we can start forming the, I would say, string with respect to this second A, and we can see each substring, I should say, each substring, if that's a palindrome or not. Now, that naive way will provide the solution, I would say. But again, if you are just interested for a working solution, I think we can very well go ahead with this. But I think as a data engineer or as a data personnel, I think we have a great opportunity here to, I would say, showcase our efficiency skills here, optimize this solution, and stand out from the crowd. So remember, I think I spoke about this previously also, that given the competition, given that everyone can present a working solution, but if you want to stand out from the crowd, I think it's fairly reasonable that you speak about the optimized solution also. So let's think around the optimization for this. Okay. And I already told that the naive way would probably, like for each character, if you're trying to form the string, first of all, substring, like with respect to this A, you are trying to check this double A, then double A B, then double A double B, if that's a palindrome or not. So first of all, forming the substrings will itself be O of n square. And then checking for each substring, if that's a palindrome or not, that will be O of n in itself. And in conclusion, this will be O of n cube kind of a solution, which will be very, very inefficient for a very large data set. So that is where I'm thinking about an optimization here. So the first thought process which I am thinking about is how do we exactly form a palindrome? I mean, given any set of characters, any string, it can be odd length, it can be even length, the given string. So let's take those two scenarios and I'll tell you what I mean. So let's take the example that we are given. We are given this race car. If you see, this is odd length. So let me take this and put odd length. Okay. And then we have the even length, which is given like this. So this is the string of even length. Now, if you observe here with the odd length, we have two R's is what I observe. We have two A's and we have two C's. And there is one character which is not even in length. The rest of the characters are even in length. I would say this point would become much more clear if I explain you this even one. So with the even length of string that we have, each character is present even number of times. And if that's the case, forming a palindrome is pretty easy. We can start placing palindrome. Essentially, the property which we have to notice is that from the front, from the back, it should be same. We know that we have even set of characters. So we can start placing one A at the front, one A at the back. Then move on, one B at the front, one B at the back. Then move on, C at the front, C at the back. And that's a palindrome for you. So essentially, if we observe with even length of the string, what we can do is we can very easily say that if all the characters in the given string are even in length, we can simply take the length of the string itself, and because that will be the longest palindrome, because we can then utilize all the characters to actually form the palindrome, as we just now saw in this example. It will be like very straightforward if the characters are even in length. The problem will come when the length of the string will be odd in length. In that case, we might need to think of a few use cases, is what I'm thinking. A few use cases or few examples to consider that what strategy we should be thinking about. So in this one, I can think about that if for whatever characters are even in length, I can take their length for the even characters. So that would be pretty easy. In the case of characters which are odd in length, for example, in this one, we have E. So for that, we need to consider that the characters which are odd in length, we obviously cannot place that towards the end or maybe towards the beginning, because then it would violate the principle of a palindrome. The best placement for an odd character, as you can see in this example, is exactly in the middle. So that's a clue. That's a clue which I'm thinking about right now. If there is only one character which is odd in length, I think it's pretty straightforward again, that I can take the length of the even characters and I can just, add the length of the odd character, and that's it. But what if this odd character, I mean, it will not always be one, right? For example, what if I say that we can have a string where we have four A's, two C's, and then we have a D, we have three Ds. In this case, again, I can have two A's in the front, two A's at the back. I can have one C at the front, one C at the back. And then we have three Ds, okay, when we have three Ds. So we can have all the three Ds here. We can have all the three Ds here in the middle, and this would still be a palindrome. So essentially, the property which I observed, that I can just add the length of the odd character and it will still work well. It is working well in this case. So can I do that? Can I just take the length of the even characters and simply add the length of the odd character? So while that may work, I'm thinking, but one of the edge cases here is what I'm considering is that what if we have more than one characters with odd length? For example, if we have an E, let's say E has a length 3 here, okay? So in this case, if I add E here, this would not be a palindrome for sure. But what I can do is maybe I can add a D like this. I can add an E here and an E here. And as I see, it is AACDE. Okay. Yeah, I think this is a palindrome. AACDE, DED, AACDE, DED, Yeah. So this is an interesting use case, actually. This is an edge case, which I'm thinking that if I have two characters which are odd in length, I can see that, oh, okay, so this is the property I'm observing. So this D, what I can do, I can actually subtract 1 from this. That would make it 2. And I can then place 1D at the front, 1D at the back, same logic which I was applying. 1D at the front, 1D at the back. Then similarly for 3 also, I can subtract this 1 and I can similarly place 1E at the front, 1E at the back. And then I am left with 1D and 1E. So I can choose only one of them, because if I choose both of them, it would violate the palindrome, because then the string would no more be a palindrome. So I can actually choose any one of them and that would be a perfect palindrome. I can actually choose a D or I can choose an E and this would still be a palindrome. So I am actually coming up with a certain logic here. I'm actually coming up with a certain logic. In fact, it kind of comes down to some kind of mathematical formula is what I can see, And I would just very quickly like to see if there is another edge case which I would like to think. So I can see that the odd characters, I have to subtract 1 from them so that I can make them even. So essentially, the property which I'm concluding here is that I have to, if the characters are already even in length, I don't need to do anything. I can simply take their length. But if they are odd in length, I need to make them even by subtracting 1. And at the end, I can simply add a +1. Because if you see what I said just now, that in the end, when I have made use of these 2D and 2Es, I still had a palindrome string, but I could still get a longer palindrome string by including any one of them. As you see, we are left with 1D and 1E. We can put them to our use and we can still increase the length of the palindrome by utilizing any one of them. So I think in the end, doing a +1 after all that activity is the mathematical equation that I'm coming up with. And I'm just thinking of few more edge cases. So equal length of odd characters. What if, I have something like, I'll take this. What if I have unequal length of odd characters? Let me take that scenario also. So let's say D is 3, E is 1, let's say. Okay. So similarly, again, I can have the same thing, AA, then C, and then I can subtract 1 from the D. So I can have 1D here, 1D here, and then I can just add the E here. Okay, just a moment. Okay, I think, yeah, this is working. This is working fine. So what I am doing here, I still went with the logic of subtracting -1 here. And if I subtract -1 from this, so equals 0. So whatever I'm getting by converting that odd length character into even, I just simply need to add that to my intermediary string, which I'm trying to make a palindrome. Sorry, this one will be 2. So I added 2 Ds here. This E1 -1 is 0. So I added 0 E's, which essentially is nothing. That's fine. And in the end, I'm left with 1D and I'm left with, I would say, 1E actually. Okay. In the end, I'm left with 1E. All right. So essentially what this signifies is the initial number of odd characters minus this number. So 1 minus 0 is 1 and 3 minus 2 is 1. So I'm left with 1 again. And in the end, I can actually just choose either I can put this remaining D or this remaining E, and that would be the maximum length of the palindrome. Yes, I think the +1 logic, adding +1 at the end, is still working here. So I think this is the logic which should work in this case, that we need to take or keep an account of the number of characters that we have in the given string. That we can do with a dictionary in Python, I would say. And essentially, as we realize, if the count is even, well and good, I can straight away add to the length. If the count is odd, I think I will start with the intermediate length by, subtracting 1 from that odd length characters. And once I have that intermediate length, finally, I'll just add a +1 to that. And that will be my result is what I'm thinking. So that's the logic. I think that should work. And essentially with this, what I'm doing is I am just iterating over all the characters once. Like I essentially have the dictionary. It will be O of n only. In fact, if it's, although there is nothing like as such mentioned in the question, but I think it will be mostly lowercase English letters. So it will be, in fact, the time complexity as I see, in the worst case, it might be O of n, but I think it will be O of 1 if I'm not wrong, because in the hash map, I'll have a maximum of 26 characters only. Yeah, I think it will be a maximum of 26 characters in the hash map. And I have to just iterate over the hash map. So I think it is a very, very huge improvement. If I'm not wrong, the time complexity is going to be linear here. It's not going to be even O of n, because if the string has only lowercase English letters, I can simply create a hash map out of that. That will be a maximum of 26 characters only. And I just have to iterate over the hash map. So I'll be iterating over maximum 26 characters. That's linear time complexity. Space is also O of one, I would say. That's also linear here. I'm not sure. I don't remember exactly if I linear is the word, but O of one. I would simplify it. O of one is the time and the space complexity as I see. So I think that should work. Let's try to put this logic into code. This is the function. I think what I will do first of all here is that, let me think. I think a good thing to do here would be to initialize my dictionary. So let's say I'll have a dictionary called counts. Okay. And now with this dictionary, what I can do is I can actually populate this dictionary, I would say. So to populate this dictionary, what I can do is I can go over each character in my string. So for each character in my string, I can get method on my dictionary. So counts.get. And I would say that, okay, get me the current count of that CHR. And if it is not existing, take that as a zero. The default value should be taken as zero and just add a +1 to that. Okay. So essentially, I'm not doing anything fancier. I'm just populating the dictionary. If the character exists in the dictionary, then just add a +1 to its value. That is its frequency. If it does not exist, then just initialize it to zero. That is what it is doing here. Okay. Initialize it to zero and then it will add a +1. So that will be the first occurrence of that character. I'll just put a comment here that I am populating the dictionary. That is what I am doing here. Okay, great. Now, after this, what I can do is I can actually have something like I should have a resultant. I obviously would need a result count, or I would say longest palindrome length. Okay, longest palindrome length. That would be a variable that I would need. I will initialize to that to zero because this is the one where I will keep a track of the length. And essentially this will be my final thing that will give me the length of the longest palindrome that I have arrived at. That's one thing. Okay, let's move ahead. So that would be here. And once I have that, what I can do is now I need to iterate uh, my dictionary that I've created. So I will create an iterator kind of a variable, use just an underscore for this. And another thing which I'm thinking is I'll access both the key and the value at the same time. So I'll just take the value in the form of this iterator variable count. And I can do, if I remember the syntax correctly, in counts dot items. I think that's the syntax by which I will get access to the entire record, entire item in the dictionary. And once I have that, what I need to check is I need to check if that, if that value, if the frequency of that current character, if that's odd or even, because that is where my decisions are based on. So I would check if that count mod 2 equals zero. Oh, I'm sorry. I should do an if here. So I will check that if that mod 2 is a zero, that means it's even length. So if that's the case, what I can do is I can simply just add that to my length that I'm maintaining. So I would add this to, yeah, I can simply do this CNT. That should just, get added to the final resultant that would represent my longest palindrome length. So that's for the even length characters. What can I do for the odd length? That's the tricky part for this question. So odd would obviously come in the else part here, because if the value mod 2 is not equals to zero, that means that's an odd frequency. And with that, what I would do is I realized and I talked about that we need to, yeah, if I go back here, we need to, do a -1 here with that length. And whatever is the resultant, I will add that to my final result, which I'm keeping a track of the longest palindrome length. Because if you see in this, what we observed was we arrived at the, by -1, we arrived at even length. And as far as we have even characters, I think we can simply just add that. That's what we are doing here. That's what we have done here. So the way I would do that is CNT -1. I'm subtracting -1, whatever the value that comes up, I'm adding that to the final resultant longest palindrome length. So that is something what I will do. Now, is that all is what I'm thinking? Okay. Yeah. And in the end, I need to do a +1. So yeah, I think this is all what we need to do. Like for the even thing, we are simply adding it, fine. For the odd length, we are adding it after doing a -1. So that till here, I think it is fine. And finally, we arrived at this Like whatever we get out of all of this, we just have to do a +1 at the end for the reasons that we already discussed actually. So I can actually, after this for loop, what I can do is I can take this longest length and I can do yeah, I can simply do a +1 to this. Yeah, I can do a +1. This should work. This should work. Right, this should work. I think that should work. I'm just thinking because I don't think anything else is needed for this question. Anything more is needed for this question. And I can go ahead and return this length that I have captured all this while. This will be my final result. Now, while I think this is going to work, this was anyways pretty much the idea that we discussed. I'm just thinking about the edge cases now. Since I'm almost done with this question, I think it's a good time that we should be thinking about edge cases once we feel that we are confident about our answer. So as far as the edge case is concerned, okay, what can be the edge cases? Have we handled a null string? Okay, so we can actually check if len of s, or instead of that, I would say if s equals null, um, I would just simply return a null, simply return. Yeah, I would simply just return from there. I think this should be good. But I think the string would never be null, but that's still fine. I mean, we can actually take care of. This is one of the edge cases I can think of. The other edge cases which I'm thinking about is, so right now we considered the odd length also. What if there are odd characters present? And what if there are only odd characters present? Odd length characters present, then also this will work. I don't see an issue with this. If, yeah, okay, this is an extreme case that I need to think that what if only odd and only even are present. So, okay, let me first take it if only odd. Let me first complete that thought process. So if only odd length characters are present, it would always keep on going in this else loop. It would always keep on going in this else loop. Would work perfectly fine. And in the end, we just need to take one of those characters and +1, we can do maximum. So I think that would work if only odd length characters are present. If only even length characters are present, then it would keep on going into this. Okay, great. But oh, I see. There is an issue here. For if only even length are present, then also it is doing a +1 here, which is not the right thing. For example, this case exactly. This is the example. So in this case, the length was 6. So if we go by this A2, B2, C2, it would just keep on adding 2 to 2. So this would already be 6 by after coming out of this for loop. And on top of that, we are still adding a +1. That would become 7, which would be incorrect answer. So I think this has to be done only when there is or there are odd length characters present. And I think I can do that. I mean, whenever there is something like this, that there is a case situation that only if this is present or this situation happens, then perform a certain action. I think we can think about utilizing some kind of a flag variable. So I think, yeah, this might be a good place to initialize it. So I can use a variable called found odd. I can initialize that to false. In fact, in Python, we have false as capital. And if we go into the else loop, that means we have an odd length character. So I would do this, or I would turn this flag as true. I would change its value. And I need to do this +1 only if there are odd characters present. So I would say if the found odd flag is true, then you should do this. Okay, now I think this would take care of that situation, and this should run for all the different use cases. I don't see any issues here. Overall, I think the time complexity, as I discussed for this, is O of 1, because we are essentially creating this dictionary. The iteration happens over the items in the dictionary, which will be a maximum of length of 26, since we are dealing with lowercase English letters. The space complexity is also O of 1, because at max size of the dictionary will be 26 because of the lowercase English letters again. So let me just test by running this code, and then I'll submit it. Okay, some syntax error I can see. Mm, oh, yes, yes, yes. S double equals, right? I'm doing a comparison here. Let me see. You see the effect of dealing with multiple languages at the same time. So I keep working with Java, I keep working with JavaScript, and the comment syntax goes for a toss there. So I forgot what is the comment syntax in Python. You see there, I use the Java syntax, but now it should be fine. Okay, my code output is 0, expected output is 7. Okay, let me check this. Why is it happening like that? For character in S, counts.get +1. All right. Uh, counts dot items. Mm, Okay, all right. I can do a plus one. I think what I'm not doing here. Hmm. Okay. So I am iterating, I'm populating the dictionary. That looks fine to me. I see what I'm not doing here. I am just, I'm never assigning here. So the dictionary, how do we access the value in a dictionary? We specify the key. And when I get the value for that key, where am I assigning it? So this is the issue with the code. So now what I'm doing here is I'm assigning the value for that particular character. Yeah, this should be it. This should work. Hmm. Okay, this is some weird error. Uh, counts CHR. Okay, if I do a counts CHR, and if I do a get CHR, I do a zero, I do a plus one there, that's fine. So I am getting all these items. This is fine. This looks fine to me. And if I'm checking if that count mod 2 is equal to zero, then I'm adding that to the result. Else I am doing this. Else I'm doing this. Let me run this again. Uh, some weird software related, platform related issue, but nevertheless, it happens. Sometimes it happens. It passes the test code. Yeah, I doubted that because anyways, I couldn't see any issues with my code. And if I submit the solution, it should also work. And there goes the congratulations. Yeah. So that is the solution for this code. And overall, as I spoke earlier, I think we have already spoken about the time and the space complexity. The solution works fine. And you can see for all the different test cases, it works perfectly well. So overall, as I said earlier, that this question, I think it's a pretty good question to test the coding and the problem solving skills for data personal especially. And as you saw, while this may have looked as a pretty straightforward thing, but it did test the logic building part where we needed to come up with different edge conditions. We needed to check for certain scenarios, and we needed to be thorough with the logic of building the palindrome and the different conditions associated with that. So I think that's all for this question. I hope you learned a good bit of things out of this session, and I will see you in the next session sometime very soon. That's all from my side. Bye bye.